Okay, this is saying right here, this is saying take the, or find the antiderivative of 2x. So we say we take the integral of 2x dx. Well, my thought process here is that I took the derivative of something to give me 2x. What would have done that? Well, I know that if f of x equals x squared, when I take this derivative, this 2 is going to come out front. I'm going to subtract 1 from it, which will give me 2x to the first, or simply 2x. So the antiderivative here must be x squared plus c. I need that constant of integration there. Now, let's go over something here quickly. If I say that f of x equals x squared, the power rule, the general power rule says, okay, I'm going to take this down here and I'm going to subtract 1. That's why I just said up here. But notice what I did to go backwards. Now I have this antiderivative that I need of 2x dx. Well, if I take 2x and it's to the first power, if I add 1 to it now, I'm going to get the 2 back that I started from. And if I divide by this, it's going to divide out that 2 that I would have gotten when I took the derivative. And when I do that, these cancel, and I end up with x squared. So this is the power rule, the general power rule, working backwards is really what this amounts to. So just as I can take derivatives through a polynomial, I can take antiderivatives through a polynomial. So using this type of logic, I'm going to work my way through here. So if I break this down piece by piece into all these individual antiderivatives, I could write each one as x cubed dx minus the integral of 2x squared dx plus the integral of x dx, and take these piece by piece. Now here I'm going to have x cubed, so I want to add 1 to the exponent, and I'm going to divide by that same amount. So that's going to give me x to the 4th over 4 plus c, but I have a bunch of these, so I need to call it c1, minus, here I'm going to do the same thing, 2x squared, so I'm going to add 1 and divide by 2 plus 1. So that's going to give me 2x cubed over 3 plus c2 plus the exact same thing here. This is x to the first, so I'm going to add 1 and divide by that amount, which will give me x squared over 2 plus c3. Now all these c's are constants, so I'm going to simply write this as x to the 4th over 4 minus 2x cubed over 3 plus x squared over 2 plus c, because I took all these constants, combined them together, and said, hey, it's just a constant. So there they are. In reality, if I work through this, I probably will not even bother writing all these constants because I know it's going to come all together right there. Now notice if I take this function and I take the derivative of it, so d dx of this function, I'm going to have 4x cubed over 4, that's a cancel, minus 3 times 2x squared over 3, so the 3's a cancel, plus 2x over 2, that's a cancel, and the derivative of the constant is 0, so I end up with x cubed minus 2x squared plus x, which is exactly what I started out with right here. The reason I want to go through all that is because anytime you find an antiderivative, if you want to check it, take the derivative. If you don't get back to the original function, you did something wrong someplace. See here, if I do d dx of x squared plus c, I get 2x plus 0, which is just 2x, which is exactly what I started out with.